Okay, hello everyone. Today in this class we are going to discuss about Fourier transform of Gaussian distribution function, which is in the form of e to the power minus ax square. This is one of the important question. Okay, very important question, I can say. Very important as per your BSc examination point of view. Okay, that means you can expect that 95% chances that you are going to get this question in your exam. Okay, so watch carefully and write down the note. Okay, so let's start. The Gaussian distribution function is given, or we can consider fx equal to e to the minus ax square, where a is greater than 0. Now we want to find out the Fourier transform of this function. So obviously we have to apply ft, that means Fourier transform on this function. That is Fourier transform applied over this function fx, or some books instead of ft, f dot t, some books written as capital F, that means Fourier transform applied over fx. In general it will be written as 1 by 2 pi root over minus infinity to plus infinity fx, the given function, into e to the I omega x dx, that we know. Now we are going to be put instead of fx e to the power minus ax square, okay, for further simplification or further derivation. So that implies Fourier transform of this function fx will be equal to, here we have to write instead of fx this one, 1 by 2 pi root over minus infinity to plus infinity. Instead of fx we have to write e to the minus ax square into e to the power I omega x into dx, okay, dx. That implies Fourier transform of this function will be equal to 1 by 2 pi root over minus infinity to plus infinity e to the minus ax square plus I omega x into dx. These two power will be add up, is equal to 1 by 2 pi root over minus infinity to plus infinity e to the minus ax square. Here I am going to be add two terms on the power of your exponential. Carefully you have to watch. Plus I omega x, I added one term, that is your omega square by 4a, and subtracted that one, omega square by 4a. So obviously this will be 0 and the previous one, only just I added this term and subtracted, right, into dx is equal to 1 by 2 pi root over minus infinity to plus infinity. This one, see, considering these three terms, we can write e to the power minus x into root over of a minus I omega by 2 into root over of a whole square, okay, whole square into e to the power this term, e to the minus omega square by 4a into dx, okay. Here you can see, if I am going to be expand this one as a minus b whole square, we can found this one only, this much only, we have to check, okay. Here you can see that this is the x into root over of a I omega by 2 root over of a whole square is there. So we have to consider a minus b whole square. So this square means x square into a, and this square means plus I omega by 2 root a whole square, then minus 2 into x root over of a into I omega by 2 root over of a. So here x square a, and this value will be I square, means minus omega square by 2 root over of a is there. So 2 means 4, it will be 4a. Here 2 got cancel, root over of a got cancel. This will be x I omega, x I omega. Okay, so if I am going to consider minus, here minus is there, so put minus over here, then it will be minus ax square plus omega square by 4a and plus I omega x. Okay, same thing we get. Okay, minus ax square plus omega square by 4a plus I omega x. Okay, for simplification we done these things. Okay, so is equal to okay, now we are going to consider this value equal to y. Now consider this one, x root over of a minus I omega by 2 into root over of a equal to y. Okay, so take the derivative both the side, so it will be root over of a into dx. This will be constant, so obviously it will be 0 equal to dy. So that implies dx will be dy by root over of a. So now this much will be how much? So that implies Fourier transform of function f of x equal to 1 by 2 pi root over. See here limit also it will be same, here minus infinity to plus infinity. So for x if I am going to put plus infinity, then y will be plus infinity, minus infinity, y will be minus infinity. So limit is not going to be changed, same it will be. So minus infinity to plus infinity, then e to the power minus y square, because we consider this much value is your y, e to the minus y square into e to the power minus omega square by 4a, e to the power minus omega square by 4a into, instead of dx we have to write dy by root a. Okay, so that implies Fourier transform of fx will be equal to, here you can see with respect to y we have to integrate, so this will be constant and root over of a also constant will be taken outside, into e to the power minus omega square by 4a into 1 by root over of a integration minus infinity to plus infinity, e to the minus y square into e dy. Okay, here you can see that e to the power minus y square is a even function, so minus infinity to plus infinity is there, so we can write 2 into 0 to infinity, so that we have to write Fourier transform of fx. Okay, so here 1 by 2 pi root over is there into e to the power minus omega square by 4a into 1 by root over of a into 2 into 0 to infinity e to the power minus y square into dy, right? This integral is nothing but a gamma function. Okay, gamma function, you just recall gamma function. You can also go through a short video I have been uploaded. In that video you can find that if we have the integral like this 0 to infinity, I have to write here, we know that 0 to infinity x to the power integration x to the power n e to the power minus a x to the power m into dx, then this will be nothing but 1 by m into 1 by a to the power n plus 1 by m into gamma n plus 1 by m. Okay, so if I am going to compare this integral and this integral, we can found n here you can see here y to the power 0, here we can write y to the power 0 into e to the power minus y square dy. So if we are going to compare this integral and this integral, so obviously n will be how much? Here you can see x to the power n e to the minus a x to the power m into dx, so it is in the form of y. So x to the power n, here y to the power 0. So if I will compare this integral, so n will be 0 and a value will be equal to 1 and m value equal to 2, right? So therefore the integral, this one 0 to infinity y to the power 0 into e to the power minus y square dy will be equal to, here you can see 1 by m, that means 1 by 2 into 1 by a to the power n plus 1 by m. A means 1 to the power n means 0 plus 1 by 2, whatever may be, this value will be 0, this value will be 1, because 1 to the power something will be 1 into gamma n plus 1 by m, that means your n equal to 0 plus 1 by m2. Okay, so this value will be how much? You can see 1 by 2 into this value will be 1, gamma 1 by 2 will be nothing but 1 by 2, this value gamma half is nothing but root pi. Okay, root pi. Now that implies here we have to put this value root pi by 2 value here we have to put. So that implies Fourier transform of the function, here function means Gaussian function, we have been considered as e to the minus ax square, right, will be equal to how much? It will be 1 by 2 pi root over into e to the power minus omega square by 4a into 1 by root a into 2 is already there into this value, because this value is nothing but this integral value will be 1 by 2 into root pi. So finally what we found? That implies Fourier transform of fx or Fourier transform of Gaussian function, whatever we consider, e to the minus ax square will be equal to, here you can see that 2 got cancel. Okay, so here root over pi will be got cancel, and we found that here root over of a, root over of 2 is there, so this will be value is your, here you can see e to the power minus omega square by 4a by root over of 2a. So this is your Fourier transform of a Gaussian distribution function. Okay, this is in general. So if I will change the value of a, then this value will be changed. That means suppose we are going to consider suppose in your exam it is asked that find out the Fourier transform of suppose e to the minus x square. So if I will compare this and this, here a value is 1, so what will be the value? This will be e to the minus omega square by, instead of a we have to write 1, so it will be 4 by, here a means 1, so root over of 2. Suppose in your exam it is asked Fourier transform, find the Fourier transform minus 3x square, that means instead of a we have to put 3, so e to the minus omega square by 4 into 3 12, e to the minus omega square by 12 by whole root over of 2 into a, that means 2 into 3 is your 6. Okay, this is all about your Fourier transform of a Gaussian distribution function. Okay, so watch carefully this video, write down the note and ready for the next class. Thank you so much for watching this video. Thank you.